Here we design and print the 3D objects we use for our experiments. This is an unstable food bowl we use to test the cognitive flexibility of the anoles.
These mealworms are used to lure the anoles. We use cameras to document the behavior of the lizards, and thereby we can also extract the breathing frequency and the color change to measure the arousal of the anoles.
This is not a typical situation for our reptiles. Let's see whether they will find the food hidden in such a strange geometrical object. It would prove their ability to deal with completely new situations. It's slightly weird to start an entirely new branch of research being in one's 50s. But I was curious to see what the cortex is good for. I thought I should study what reptiles are able to do. We study the evolution of the human brain. Reptiles are descendants of the first animals that feature a cortex. Their cortex is comparatively simple, only 3 layers, not 6 like human neocortex. But it has survived evolution. Human hippocampus, a central building block of human memory, is a 3-layered cortex, just as reptile cortex.
To explore how reptile memory and cognition works, we first have to find out what they are capable of. A lot can be done by making them work for their food. That is why we use simple visual discrimination tasks in T-mazes, where the right choice is rewarded with food, and we also train them to respond to food calls. That means each lizard is trained to respond to a specific sound pattern and associate that with food. So we can use that to call them to our experiments. Right now, we are working on an experiment that tests their ability to modify their behavior to solve problems. Each experiment is filmed, so we can later assess their breathing rate and color change and other signs of arousal. We also wanted to test a much simpler brain. That is why we started experimenting on flatworms.
Plants are intelligent. Mushrooms are intelligent. Animals are the first to do it with a nerve system. And the first animals to feature a structured nerve system, resembling a rope ladder, with cerebral ganglia, a kind of a brain, are these flatworms. I'm still blown away when I remember how we started a year ago. Nothing but a shabby container full of rubbish. And now we have an animal housing, our own breeding of food animals, a modular experimental setup, and the first experiments up and running.
The lizards were able to modify their behavior to solve this problem. However, they have yet to learn how to solve the next step.